Hello everyone. Welcome to AI SRE Engineer series. I'll start with a simple use case. Imagine you are responsible for a Kubernetes production environment. The application is still running. Users haven't started complaining yet, but CPU is increasing. Memory usage is also climbing. Pod restart counts are growing. Something is about to go wrong. The problem is most engineers don't spot it until an incident occurs. What if AI could analyze your observability data and warn you before things become critical? Today, we will build an AI observability agent that combines Kubernetes, Prometheus, Grafana, and our local LLM, Mistral, along with Ollama to automatically analyze system health and generate intelligent observations. This setup will be very important. So let's do it. I'll start our discussion with a simple architecture diagram. So the architecture looks something like this. We already have a Kubernetes cluster, which we created in our previous episodes also. So in case if someone did not watch the previous episodes of AI SRE Engineer series, I strongly insist so to go and watch previous episodes as well. So as a part of this episode, we do have already Kubernetes hosted by using kind. Now the Kubernetes data will be scrapped by Prometheus. Prometheus will pass the data. Prometheus will act as a data source for Grafana. Grafana will again pass the data to AI Observability Agent. An AI Observability Agent will perform health assessment, root cause hints, and will also provide certain recommendations as well. Setup is very simple, as you can see. Now, this is our GitHub link. GitHub, it's the same link which I'm sharing you from episode 1. Anyone who wants to use it can simply fork it and use it. The today's video do have everything automated, which we are going to see in few minutes. Everything will be automated. We just will run the prompt and it's the AI agent which is going to do everything whatever it is. Let me quickly explain the setup of this repository so that when you are using it, it will be very easy for you. I have already created and explained Kubernetes folder and the content of Kubernetes folder in our episode 4 also. In Kubernetes folder, I have intentionally created certain deployments which will fail so that we can see those error messages, logs, and how our local LLM model responds to it. Now, also I have created certain scripts. Under these scripts folder, I created two folder. One is for Linux and another is for Windows machine. Under Windows machine, I have created certain PowerShell files. These PowerShell files will deploy all the use cases. In episode 4, we ran these use cases. We executed kubectl command to run these use cases to deploy these YAML files. But in this episode, everything will be automated. And don't think that we are going to execute these PowerShells. We are not going to do that as well because we are learning AI SRE Engineer. We are in a AI SRE Engineer series. Everything will be done by AI. We are just going to run the prompt. Right prompt will do everything for us. We are not going to run any PowerShell script. Just to give you an idea, I'll just show you what this PowerShell script contains and what these PowerShell scripts are meant for. So this PowerShell script, which is deploy use cases, will deploy all the use cases, will run crash app YAML, which is nothing but the content of this Kubernetes folder, will run DNS app, mem app, and DB error app. All these fours will be executed. Next is install the observability part, wherein, like the way we saw in our architecture, Kubernetes will pass information, all the details to Prometheus. Prometheus will be scrapping data from Kubernetes, and later on it is passed to Grafana. And Grafana will further pass to AI Observability Agent. Quite the same thing happens here also. Here with this script, we'll be launching our observability tools. such as Prometheus and Grafana. I'll be using Helm for that purpose. And after its complete execution, after its successful execution, what happens? Grafana will be hosted and will be available on port number 3000. And Prometheus will also be hosted, and Prometheus will be available on port 9090. The username and password of Grafana will be admin and admin123. The username and password is explicitly set in observability values.yaml file, which is present in the root directory of our repository. So in the root directory of the repository, which is this, if I click on observability values.yaml, you can see values are defined. So the default username for Grafana is admin, and I've given the password also admin123. Say in case if you want to change it, if you want to keep a password of your own choice, you can do that. You can simply edit this file and can easily manage that part. So this is about setting of observability. This is about setting of your use cases, executing of deployment. But there could be certain situations wherein you want to clean up everything. So I created certain scripts which is for cleanup of use cases, also cleanup of deployment file also. So as this script will be executed, there will be automatic cleanup of all the deployments which you have created. Also, there is a cleanup script for observability wherein all the observability components will be cleaned up. Same thing is there for Linux also. Say in case if any of the viewer wants to execute similar type of script for Linux operating system, will follow this specific script. Now, like the way I said, we are not going to execute anything on our own, not even a single script. Everything will be done by AI agent. So I'll be using GitHub Copilot to execute these scripts for me. For that, I do have a prompt in place. Again, in the root directory, I have two prompt files, prompt setup and prompt cleanup. Again, I'll quickly go to GitHub and I'll show you the content of the root directory. Now in the root directory, again, you can see I do have prompt cleanup and prompt setup. So now as I click on prompt cleanup, it is going to show me the prompt which is going to perform all the cleanup. We are going to execute this prompt also. And second is prompt setup. This prompt will set up everything for you. It will set up observability, it will set up all the deployments, and will make everything ready for you so that you can just use it and you can just view the Kubernetes logs there in your Grafana dashboard. So this is what we are going to see in our demo. Just to give you a quick review, what we are going to do, we are going to use AI prompts and GitHub Copilot to create entire setup for us. We are not going to execute even a single command. We are not going to execute any of the script which I have shown you, neither in Windows nor in Linux. We are just going to run this specific prompt, and this prompt will create entire setup for us. So let's do it. Let's run the prompt. So I'll go to the raw mode and I'll copy this prompt. And as I copy this prompt, I'm going to execute this. So let me just copy this prompt, and this prompt is for setup everything ready for observability demo. As of now, just to show you, just let's run kubectl get pods and let's see if it is having any pod available or not. So if I run kubectl get pods, you see there is no resource found in default namespace. Now in my GitHub Copilot chat, I have kept the LLM as auto, and I have just chosen the mode as agentic mode. So now I'm going to paste the prompt which is going to set up everything for me, and I'll run it. It will take couple of minutes for everything to keep it ready, hardly a minute or two. Now you see the agent started running. it is reading the script. It has read both the script, observability script, as well as the use case script. And now it's asking my permission to allow the execution. So I'm going to allow all commands in this session. So now you see it is executing this specific script, observability install observability.ps script, PowerShell script. And after it does it, it will also execute the deployment script. Let's wait for a few more seconds. Now it is waiting for Grafana to come up. You see, the Grafana is coming up. It is going to install the Grafana and then it will host the Grafana. It will do port forwarding also and will launch Grafana. On which ports Grafana will be up. It will tell you those things also on which ports Grafana will be launched. Now in few seconds it will be up. So now this is up. This is up. Now what it has done, it has executed the PowerShell script for observability setup and brought the Grafana and Prometheus up. Now let's see if Grafana and Prometheus is hosted. So now Grafana is available there on local host 3000. And as you hit enter, you see the Grafana dashboard is up. I'll show you after running the cleanup script, it is going to clean up everything for you. So now in order to log in, you just put in admin and admin123, admin123 is the password. Now your Grafana dashboard is up. Let's see if Prometheus is up. So local host is hosted in port number 9090 and Prometheus is also up. So there might be a question in your mind, why 3000 for Grafana and 9090 for Prometheus? Because this is what we have defined in our port forwarding concept. Let's go back to the script and let's see the observability script. In the observability script, as you can see, the port forwarding command, the port forwarding for Grafana is done on port number 3000 and port forwarding for Prometheus is done on port number 9090. That is the reason it's available there on port number 9090 and 3000. Okay, so now everything is up, everything is ready. Now, as you have noticed, with just one single execution of prompt, your entire setup is ready. Now, like the way we saw in episode 4, if I run Python script, and I call SRC, and under SRC, my app file, and I'll say app as DNS, it is going to call the local LLM. Like the way you can see, it is calling the local LLM, doing all sort of evaluation, also running all sort of commands also. Like the way I said in our previous session that I'm not going to execute any command manually. Everything will be done by my prompt by agent only. Now you see, I just ran this specific script, which is app.py, and everything it has called the investigation agent. It has executed all the commands. It has executed get pod command. It has executed kubectl log command. It has executed the command to verify the pod statuses as well, which is faulty. And after few minutes, it is also going to give you the prompt, going to give you the messages from LLM as well. It will take few minutes, maybe 1 minute or two, for LLM to pull all the responses. In the meantime, let's go and see what is there in Grafana and Prometheus. We have Grafana also hosted. Now Grafana is already monitoring your Kubernetes cluster. Now let's go and see that thing. Grafana is present. Now you can understand launching Grafana is a easy task now. To give a brief what we have done till now, we have run the setup prompt and we have used GitHub Copilot to create the setup for us. When I say create the setup, it has basically hosted Grafana, hosted Prometheus. Grafana is available on port 3000. Prometheus is available on port 1990. And after that, it has executed all the deployments as well. Now, under Grafana, it has also created dashboards for us. So now if I go to Grafana, under dashboard section, you see these many dashboards are present. Now, I'll show you one dashboard, but I'll strongly insist you to go to multiple dashboards. Under this, you see at the left side, there is a dashboard option. Once you click on that dashboard, you will be able to see plenty of dashboards which is available under Grafana. Now, I'll go into one of the dashboard. We see Kubernetes networking pod. If I click on this dashboard, you see this gives more details about the DNSs, all the networking configuration of pod. At the top, you can see the namespace is Cube system at this point. At this specific place, you do have the option to change the namespace also. You can change the namespace to default, and you can change the namespace to local path storage also. Let's click on default. As I click on default, you see the values metrics are changing, and you do have long list of all the pod which is executing at this point of time. Crash up pod, DB error pod, DNS error pod, memory pod, different monitoring pod which is created is also getting executed. So this is what you will get in your Grafana dashboard also, and how it came with just execution of one single prompt. Now, let's see if the LLM, local LLM has generated certain responses or not. You see, local LLM is doing its job and started generating its responses. It is giving incident summary. It is saying that the Kubernetes pod, which is with the name this in the default namespace, is executing some error, is experiencing some error. Also, it started giving certain root causes. Also, if you'll see under evidence section, it's making very clear. It's saying that the pod status is running. Exit code is not provided, but the message is crash loop back off. Restart count not provided, but the status is crash loop back off. What is the error? Error is DNS resolution failed. Very crisp, very clear, no jargons, no extra words. It's very, very clear for us. It is also telling some investigation actions as well. It has retrieved the pod status by executing this command, and it has certain findings also which says this pod is in the running state but has encountered a crash loop back of error. It is giving you detailed information, so no need to worry and do anything. No need to worry, everything is taken care by AI itself. This is the utility. This is the benefit of AI SRE Engineer. You no need to do anything. Everything will be captured and will be done by this agent itself. Now, you saw what this agent can deploy for you. Now, you don't want to keep this infrastructure up and running for longer period of time. You want to do cleanup. So if you want to do cleanup, go to prompt cleanup, and same thing is present in your GitHub repository as well. So I'll go to the prompt, which is going to clean up everything for us. So prompt setup has created everything. Prompt cleanup is going to clean up everything. So again, I'll go to the raw mode and I'll copy everything, and I will just paste in the agent, and I'll run it. Now, what this agent is going to do? Agent is going to clean up everything for me. It is going to delete everything. It is just going to clean up all the resources for me. This is what it is going to do. In few minutes, we'll see how the cleanup happens. Now, what you have learned, how by using prompt, you will be able to set up everything first, and you will be able to clean up everything. So you no need to manually install any component. Everything is automated. One command, everything gets deployed automatically. Everything is cleaned up automatically. Now, I have intentionally created several problematic workloads like the workload of DB error, DNS error, so that you can see how this LLM evaluates it. Okay, so this is AI SRE Engineer series. This was the last episode of this series wherein we saw how we can integrate LLM along with observability. Now, the complete source code is available in GitHub. You go to GitHub, try to fork it, try to clone it, and then use it. So, if you found value in this video, in this series, like it, subscribe the channel so that it becomes more and more beneficial for you and you will stay updated for all my upcoming series also. I'll come with some new series as well with more advanced and more complex use cases. Tell me in the comment what you're looking for. Tell me in the comment what should our AI observability agent analyze next, and I'll create video accordingly. Tell me what sort of alert you want to see in Prometheus or Grafana dashboard. Or are you looking for some CPU spikes or memory leaks or any real production incidents which you're expecting? I'll create video accordingly. Now I think the cleanup ran and it says environment cleaned up successfully. Now let me quickly execute kubectl get pods and you see it has cleaned up everything. Now let's go to our Prometheus and Grafana as well and refresh the page. You see it is gone. Prometheus, refresh the page, it is gone. And how did we achieve? Just by execution of one single prompt. So thank you everyone for watching my series AI SRE Engineer. I'll create more series of similar kinds.